first distinction is one that you've already learned, I hope. Passive versus active, where passive has no moving parts and is not electrical. Passive is like your house designs, where you use sunlight for heating or cooling the air directly without moving parts. Passive, because nothing moves, has nothing to do with electricity, and is just a heat gain or heat movement to make ventilation. Passive solar is probably the least technical thing that I'll say in this entire unit. But I'm done talking about it. Because we need to look at active. Active is with moving parts. That's what the active means. Either water is moving in a water heat collector, or electricity moves in a photovoltaic. You guys know heat collectors, those water things? It's like a big panel with the pipes inside, big pipes on it, and the water goes hot through the pipes. Okay, that's out of the way. What I really want to talk about is photovoltaic, light into electricity. Photo, like photons, like light, like photographic, like paper made with light. So, photovoltaic, light into electrical. The design I'm showing you here is probably the most generic, most simplified solar panel I can possibly show you. We live in exciting times. This is 2013. By now, there's a lot of different types of solar panels. This is like the 1995 version. Not necessarily outdated. Most solar panels are like this. But the high-tech stuff of the future has different chemistry, okay? This is just like slightly outdated, early attempts. It's like alkaline batteries, you know. We still use them, but they're old school. There are a couple of chemicals here, but this isn't chemistry. And if you are nervous about chemistry, there's nothing to fear at this stage. You may have other problems with chemistry, but this isn't really chemistry. I just have a couple chemicals. Everyone must know the three layers. Silicon on the top and the bottom, and in the middle, what's called a semi-permeable electrolyte layer. And I'll explain all of this, you've got to know it. The silicon on top has boron impurities. Boron is that one. Those of you who speak chemistry, you'll notice it has a very flimsy attached valence electron. Is that the right word, valence? Yeah. So the first of the rings that are very loose has just one. So that's got a 2, 2, and then the, what is that, P, first P? 2P1?
Yeah, it's just got that little charge.
So, boron is an impurity in the top silicon. The bottom is just pure silicon. The top one has boron. I will explain why later. Remember, this is achemical. I'm not talking chemistry. It's just achemical. So boron in the silicon on top, just silicon in the bottom. And now for that thing in the middle, the semi-permeable electrolyte layer. I'm sorry, but that term will keep coming up. So I have to give you the generic explanation first. A semi-permeable electrolyte layer is any layer which allows a specific charge to travel in a specific direction. Specific charge in a specific direction. That's the definition of a semi-permeable electrolyte layer. Not all charges, not both directions. Just a specific charge, either positive or minus or negative, and just in a specific direction, either up or down or left or right. There are different layers that are for positives or for negatives. You can turn it around so the negatives go that way. You can turn it around so the negatives go this way. You can get one for the positives so they go that way, or turn it so that the positives go that way. It's like a one-way street or an entrance to a club that has a bouncer. Plumbing. Water only goes one way in plumbing. A city permeable electrolyte layer only allows a specific charge to travel in a specific direction. And this one, look up, only allows negative charges to travel downward. You can see how I made my funnels pointing that way. So only negative charges will go downward. That's what this is. Negative charges downward only. Remember, you could make a separate type of mechanism for a different type of layer, but in a solar panel, they're all this way. Negative that goes down only. So, I'd like to turn on the sun. There's my angry sun. See the big eyebrows and the teeth. Okay. That angry sun is going to send excitement down to the channel. And everybody knows that solar energy traveling through space is not heat, right? Light. Between here and the sun, it's pretty cold. We're not being heated by the sun. We're being lighted by the sun. Light travels far, heat the sun. You got to get really close to the sun before you get home. So, solar energy in the form of light strikes the boron, and people who speak chemistry, you realize that that one really loose electron is easy to knock off. But for everybody else, who cares about that? Watch. Sunlight hits boron, and boron goes boop, 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 spits off electrons. And does everybody know that electrons are negatively charged? So given our electrolyte layer, where will those negatives go? Right, they're going to go down, which is just what I told you is the one particular layer that makes all this possible. It's just a detail that you've got to know about solar panels. Because these electrons will migrate from the top layer to their new home in the bottom layer.
So they're now in the silicon?
Yep. And technically, would anybody like me to make this slightly more accurate but maybe more confusing?
Yes.
Everybody who's confused, earmuffs. Everybody who's scientifically rigorous, remember that the electrons don't actually move. They just transmit their excitement. So electricity is not actually moving electrons. It's like the wave at a stadium, where the excitement travels, but everybody sits still. Okay, so electricity is not actually traveling electrons. It is their excitement getting bumped to the next one. Okay, thanks. So watch. As a shorthand for real physics, we say the electrons have moved. That's not exactly true, but whatever. It helps us understand. So watch. If all the electrons are on the bottom side, what's the net charge of this pole? Negative. It's clustered with electrons, right? So this is now a negative side. And when you've taken all the negatives from the top layer, what's left? Positives. And check it out. It's like I just charged the battery. If I connect the wire, like Paula Abdul saying a long time ago, opposites attract, and all the negatives will travel through the wire back to meet their buddies, and as they travel through an electrical appliance, they will do work. Like lighting up your house, for example.
Do they have to travel back to the solar panel?
Yes, technically the electrons aren't actually moving. Their excitement, like the wave through a football stadium is traveling through those wires, and that excitement is spent in the form of light and heat over here.
So when they're attached to your house, do they come in, and then is there another wire running back out to the solar panel?
These are the black and white wires of any cord. If you take a wire and you cut it open, you'll notice that there are usually two separate cables, the hot and the cold, the black and the white.
Like here, there's two.
Two halves of a circuit. That's a two-way street in every wire. Yeah?
Well, I just don't understand the one reading out. That's all.
That's to complete the circuit. If you had this in the real world, it would actually be a double-sided wire.
Oh, okay, let's go back.
With two connections over here and two connections over there, but one of them is actually electricity going this way and the other one's electricity going that way. Like if you look at any old plug, the plug has two tingaderas in it, and when you cut this rubber thing, there's actually two separate wires that are insulated from each other. That's one way to the appliance back. So that closes the circuit with a single wire, but that's in and out of the appliance. It's a generic word used as a space filler, and it is also a bad word. It is something which does a verb which equates to the F word. So it's like saying the F-er. Right? Like, is that a good
yeah, you can use it. It's mostly used for bad words, so like when my friends say it, it's like doing something bad.
Right, right. It's like if you drop something heavy on your foot, you go, okay.
You know, Jose, that is, chinga is actually a mushroom too.
A mushroom?
Oh, I have a mushroom book I need to bring you.
Okay, full circle. It's always full circle. Now watch this. I got to make sure that everybody sees something kind of funny, because there's a big problem with our solar panel. Anybody have questions about the three layers, the borons, the electrons, traveling electrons? Watch. As soon as there's sunlight, the electrons don't stick, they travel, they create polarity, electrical work. When the electrons come back home, so to speak, they get kicked off the boron. This keeps happening as soon as there's sunlight. But if I were to shut off the sun or block my solar panels, put them in the shade, if no sunlight hits the panel, then the electrons stop flowing, the potential goes off. The panel is now asleep. It's a dead battery, so to speak. The electrons quit flowing and your light bulb don't run no more. Physics nerds, keep your accuracy to yourselves. I mean, you gotta admit, right? Like giving a Band-Aid to like people that haven't had physics, that's not bad, right? No. Like there was no missing information. It's just not. I mean, there's no wrong information. It's just missing. Sorry. We don't even really learn about solar panels. So what do we do when the sun is out? There are two options. More vocab for you to know. You can be on-grid versus off-grid. This was a College Board AP test question 2 years ago. They asked you these questions. Back in the day, like the hippies, back to the earth, Humboldt County, 1978, everybody's got the secret shack in the trees. Okay. That kind of solar panel, like I kind of have on my Tacoma, because my truck is a fully independent electrical system when I hit the mountains all summer. It's called off-grid. You've got a panel. Watch me. The panel charges batteries, and at night,